So coming up here, we come to the basic concepts of polar coordinates and certain basic formulas on them. So you need to remember that polar coordinates are given by x equal to r cos theta, y equal to r sin theta. So you can see this is theta and this is r. So using trigonometry, tan theta is y by x. So theta will be tan inverse y by x, because you know that this will be y, distance from the point to the x-axis, and this will be x. So now there are some basic rules that you need to know and formulas. Prove that tan phi equal to r d theta by dr, where phi is the angle between the radius vector and the tangent. So we have just drawn this figure here. You have phi is the angle, this is a radius vector and this is a tangent to the curve, and this is theta and this is psi. So using exterior angle of a triangle equal to sum of the interior opposite angles, so psi will be theta plus phi, and applying tan to both sides, tan psi equal to tan theta plus phi. Now tan of a plus b, you know, is tan a plus tan b by 1 minus tan a tan b. So this becomes equal to tan theta plus tan phi by 1 minus tan theta tan phi. So we have tan psi equal to, now tan psi equal to dy by dx, because how do you define the gradient? It is a tangent of the slope. So tan psi is dy by dx, and using chain rule, this is dy by d theta by dx by d theta. That is d theta of y is r sin theta and x is r cos theta. That follows from the figure. So we have apply the differentiate using product rule. So it is r derivative of sin theta is cos theta plus sin theta dr by d theta by, again apply the product rule, r derivative of cos theta is minus sin theta plus cos theta dr by d theta. So tan psi will be, now divide by dr by d theta cos theta. So tan psi will be r cos theta by dr by d theta cos theta plus dr by d theta sin theta by dr by d theta cos theta by, again divide the numerator by dr by d theta cos theta. So you get minus r sin theta by dr by d theta cos theta plus dr by d theta cos theta by dr by d theta cos theta. So that will give you, here you get r by dr by d theta, this becomes plus tan theta. Here you get, this reduces to this reduces to 1, and this is minus r tan theta by dr by d theta. And now you equate 1 and 2. The left hand side of 1 and 2 is tan psi, so the RHS of 1 and 2 will be the same. So I have tan phi plus tan theta by 1 minus tan phi tan theta. This is the RHS of 1 and equated to the RHS of 2. So we get r by dr by d theta plus tan theta by 1 minus r tan theta by dr by d theta. Equate, so you have tan phi equal to r by dr by d theta, which is r d theta by dr, and cot phi will be 1 by r dr by d theta. So this is an important formula which you will keep using in problem solving. Now one more application of this is something like this. If P is the length of the perpendicular from the pole, this is the pole to the tangent, this is a tangent to the curve, then prove that 1 by P squared is 1 by R squared plus 1 by R raised to 4 dr by d theta the whole squared. Now using this figure, we have sine of phi equal to ON by OP. So sine phi is P by R, so P is R sine phi. And cot phi is 1 by r dr by d theta. We just saw that here. So we have from 1 by p, take the reciprocal of 1. So we get 1 by p squared is 1 by r squared cosec squared phi. And if I were to substitute, so we get 1 by p squared is 1 by r squared. Now what is cosec squared? 1 plus cot squared. So it becomes 1 plus cot squared phi. And cot phi is 1 by r dr by d theta the whole squared. So substituting here, you get 1 by r squared plus 1 by r squared dr by d theta the whole squared. So you get 1 by r squared plus 1 by r raised to 4 dr by d theta the whole squared. And this is another important formula which you need to remember. Now, if another last point which I would like to stress is the angle of intersection of two polar curves. So if phi1 is the angle made by the radius vector and the tangent to the first curve, and phi2 is the angle made by the radius vector and the tangent to the second curve, acute angle between the two curves is given by mod phi2 minus phi1. And if the two curves intersect orthogonally, then tan phi1 into tan phi2 equal to minus 1. So this is just a basic overview of the polar coordinates which you will use later on in problem solving. Thank you and stay tuned.